Hello children, Vanakkam. How are you? I hope you are all being well and safe. Now I welcome you to the optics chapter. The previous class we have learnt about properties of light, refraction of light, dispersion of light and scattering of light. I hope you have gone through the portions. Now we are going to see about lens, its types. So at once you will have some idea where the lenses are used. First of all, the lens is made up of glass. It is a transparent medium bounded by two spherical surfaces. Let us draw the lens. First thing, lens. The two types are convex lens, concave lens. Why it is? It is otherwise called converging lens. Why it is called converging lens? It converges the light rays, so it is called converging lens. This is concave lens. It diverges the light rays falls on it. Next thing, we see the shape of the lens. It is convex, that is biconvex. Here it is biconcave. You can see it is thicker in the middle than at the edges. Here in concave lens, thinner in the middle than at the edges. Let us see the definition for lens. Lens is an optical transparent medium bounded by two spherical refracting surfaces or one plane and one spherical surface. Lens is basically classified into two types. They are convex lens and concave lens. Convex lens are biconvex. Why it is called biconvex? This side also convex, this is also convex, so it is called biconvex. It is a lens bounded by two spherical surfaces such that it is thicker at the center than at the edges. A beam of light passing through it, converged at a point. So it is called convergent lens. So it is called converging lens. Concave or biconcave lens, it is a lens bounded by two spherical surfaces such that it is thinner in the middle and thicker at the edges. The parallel beam of light passing through it is diverged or spread out. So a concave lens is called as diverging lens. The parallel beam of light that passes through the concave lens, already we have seen what is beam of ray, is diverged. So it is called diverging lens. Next we see the types of lenses: convex lens, biconvex, then plano-convex, positive meniscus. In concave lens, concave, biconcave, plano-concave and negative meniscus. So these are the other types of lens. We will see the images formed due to refraction through convex lens and concave lens. Before going to that, you must know the key points. To understand the ray diagram, let us see what are the key points. P, principal axis. Already you have learnt in 8th standard what is principal axis, what is principal focus, optic center, F focal length, U object distance, V image distance. Let us recall what are they. Principal axis is an imaginary line, you know very well, the imaginary line that passes through the centers of curvatures of the two spherical surfaces C1, C2 and the optic center O. So, principal axis means it is an imaginary line that passes through the centers of curvature of the spheres and the optic center. This is called the principal axis, P-A-R-P. Okay. So, are you clear now what is principal axis? Next we see the principal focus. What is principal focus? The rays parallel to the principal axis strikes the lens. After refraction, it converges at a point at the principal axis. See here, the rays parallel to the principal axis. After refraction, it converge at a point in the principal axis, that is called principal focus. Okay. Now we have seen principal axis and the principal focus. The distance between the optic center and the principal focus, this distance is small f focal length. Focal length, okay. So, next optic center, already I told you, it is the center of the lens, center of a concave lens or a convex lens. Next u means object distance. Suppose if we are placing the object anywhere before the lens, now object distance and image distance, we are keeping the object AB, let us name as AB, in the principal axis. The rays parallel to the principal axis converge. So, we are getting the image at the point of intersection. This is called image A dash, B dash, A dash. The distance between the optic center and the object is u. The distance between the optic center and the image is v. So, that is all. So, we have seen the key points used in the ray diagram. We are going to use this for drawing the ray diagram. We are going to see the images formed by convex lens and a concave lens. We will see the important rules used to draw the ray diagram. First one, rule 1, you can see in the picture, when a ray of light strikes a convex or a concave lens obliquely at its optical center, it continues to follow without any deviation. That is, optical center valiya எந்தாவது ஒரு ரே போனுச்சுன்னா it will not deviate, it continues its path. Okay. Suppose if you were asked one question, a ray passes through the principal focus, gets deviated or not? The answer will be, you know very well, the principal axis is the line that passes through the optic center. So, the ray that passes through the principal axis will not deviated. Okay. So, rule 1 is very simple. Let us see second rule. When rays parallel to the principal axis strike a convex lens or a concave lens, the refracted rays are converged to, if it is a convex lens, it is converged, or it appear to diverge from a concave lens, because already we have seen concave lens is a diverging lens. So, appear to diverge from the principal focus. So, you see the diagram, this is very simple. If you understand these laws very well, you feel very easy to draw the ray diagram. Let us see rule 3. When a ray passing through a convex lens are directed towards concave lens, the principal focus strikes the convex or concave lens, the refracted ray will be parallel to the principal axis. So, second rule oda just opposite the third rule. So, in second rule we have seen a ray parallel to the principal axis after refraction passes through the principal focus. But in third rule we are seeing a ray passes through the principal focus, after refraction it passes through the, it is parallel to the principal axis. In the diagram you can see convex lens and a concave lens, how the rays are deviated or gets refracted. Okay. Are you clear now? If you understand these three, then it is very easy to draw the ray diagram. Refraction through a convex lens. First column object distance, second one the ray diagram, and then the type of the image formed due to refraction is given in the third column. First one, the object distance. The object is at infinity. What is mean by at infinity? We can't measure it. That is ரொம்ப தூரத்தில் இருக்குது அப்படின்னு நம்ம assume பண்ணிக்கிறோம். When the object is placed at infinity, a real image is formed at the principal focus. Already I explained you in seeing the principal focus. In that diagram, I have clearly explained you. The rays parallel to the principal axis after refraction converge at a point in the principal axis. So, the same diagram is given here. What kind of images we are getting? We are getting a real and inverted image. What is mean by real? What is mean by virtual? You know very well, children. Already you have learnt in the lower classes. Real image means we can catch it on the screen. Virtual image means we can't catch it on the screen. Okay. For example, கண்ணாடி முன்னாடி நம்ம நிற்கிறோம் அப்படின்னா நம்ம பார்க்குற நம்ம முகம் வந்து நம்ம முகமோ நம்ம உருவமோ, it is a virtual image. We can't catch it on the screen. But a real image we can catch it on the screen. Then diminished image. What is meant by diminished? Very, very small image, where we are getting, if the object is placed at infinity, we are getting the image at the principal focus. Okay, are you clear now? The object is placed beyond 2f or c. Already I explained you what is center of curvature, that is greater than 2f. If the object is placed greater than 2f, before that what is 2f and what is f? I want to give an example. Before seeing this diagram, you must know what is f, what is 2f. Okay, I will give some example, I will explain it through a diagram. See here, this is the principal axis, the lens is kept here, this is the optic center, and this is C, center of curvature, here it is C, center of curvature. For this spherical surface, this is center of curvature number 1. For this spherical surface, this is center of curvature C2. Okay. The ray is parallel to the principal axis. What happens? Just now we have seen the rays parallel to the principal axis converge after refraction at a point in the principal axis, isn't it? This is capital F. Already I explained you, already I told you the distance between the principal focus and the optical center is small f. I explained you. Now, if for example, if small f is equal to, the focal length is equal to 12 centimeter. Okay, so we are marking this as f. Next, this is the optic center, this is principal axis. The rays coming from this side, the other side of the lens, it converge at a point in the principal axis. This is, so we are getting two principal focus for the biconvex lens, this side one principal focus, that side one principal focus. For our convenient, we are naming it as, this is f1 and this is f2. If the distance between the optic center and f1 is 12 centimeter, what is 2f? Multiply it by 2, 2f is equal to 24 centimeter. So, we are marking 2f here and this side also 2f, 2f2, this is 2f1. So, f1, 2f1, f2, 2f2. Are you clear now? So, what is 2f1, what is f1, yeah, what is f2 and 2f2. And one more thing I want to tell you, to draw the ray diagram, the real rays are drawn by bold lines. The real rays are, the real rays are drawn in bold line, and the extended light, we are going to see it in the concave lens and also the last part of a convex lens. So, that is drawn in dotted line. So, we are using two lines to draw the images formed due to refraction of a convex lens and a concave lens. So, next thing, the arrowhead is very, very important. For bold lines, we have to use the arrowhead, but for the dotted line, we should not use the arrowhead. Next, for real image, we are using, for real image to represent or to tell the real image, we are using the bold line, and for inverted image, for a virtual image, we are using the dotted lines. Okay, are you clear now? Once again, I explained this. In the ray diagram, drawing the ray diagram, we have to keep 2 points in our mind. First one, to draw the real rays, we are using bold lines, and to give the virtual image, we are using the dotted lines. In bold lines, we are using the arrowhead. These are the key things you should remember always. The object placed beyond C, that is greater than 2f. The AB is the object. Here you see the diagram, AB is the object kept beyond 2f1 or beyond C. If it is kept beyond C, what happens? We have to follow two rules. First rule is a ray parallel to the principal axis, and other ray, the ray that passes through the optic center. First ray, the ray parallel to the principal axis, after refraction it passes through the principal focus of the other side, and goes in that way. The second rule, we are using other ray, no, that ray that passes through the optic center is not deviated. We are getting the image where the two rays are intersected. Where the two rays are intersected, there we are getting the image A dash B dash. Suppose for example, in this one we are getting the image, what kind of image or what type of the image? We are getting the real image and inverted image. So, the arrowhead is downwards, smaller than the object. You see the height of the object and you see the height of the image. It is smaller than the object and the image is between f and 2f. Here f2 and 2f2. Okay, are you clear, children? The object placed at C. At C means at the center of curvature. When an object is placed at the center of curvature, what are the two rules we are following? A ray parallel to the principal axis and a ray passing through the optic center. So, the image is formed at the other center of curvature, the other side of the lens at the other center of the curvature. What kind of image we are getting? A real and inverted image, the same size of the object. You see the height of the object and height of the image. A, B is the object and A dash, B dash is the image. Same size of the object, and where we are getting the image? We are getting the image at 2f. Okay, are you clear now? The object is between, we are taking the object close to the lens. The object is placed between f and C. What is f? What is C? F principal focus, C center of curvature. If we are keeping the object between f1 and 2f1 or the principal focus and the center of curvature, the image is formed. Where we are getting the image? We are getting the image beyond 2f2, that is the other side of the lens. At beyond 2f, we are getting the image. The nature of the, you see the nature of the image, a real and inverted image. Magnified image, you see the height of the object and height of the image, it is inverted, magnified image and beyond the center of curvature, that is beyond 2f2. Okay, are you clear? Next object, next we are going to keep the object at the principal focus. So, little by little we are moving towards we are moving the object towards the lens. So, if we keep the object at the principal focus, follow two rules. First rule, a ray parallel to the principal axis, and the second rule, a ray passes through the optic center. So, that a ray parallel to the principal axis, after refraction it passes through the principal focus. The ray that passes through the optic center will not get deviated. So, we are getting the image at infinity, a real image, magnified image, we can't catch it because it is the image is at infinity. So, if you see this is the opposite of the first one, what we have seen, the object placed at infinity. The same opposite of the image we are getting. We are taking the object closer to the lens, that is we are keeping the object between or within f, we can say within f or between the principal focus and the optic center. See the size of the object, the object is named as AB. Now, follow the two rules, a ray parallel to the principal axis and a ray passes through the optic center. What kind of image? Have you noticed here? The image is virtual, the image is larger than the object, same side of the object. The same side of the object, we are getting the object at the same side of the object. It is virtual in nature, we can't catch it in the screen. Are you clear now? So far we have seen the refraction, what happens in a convex lens. Now, we are going to see the refraction through a concave lens. Already I told you concave lens is otherwise called diverging lens because it diverges the light rays falls in it after refraction. Now, let us see what happens if the object is placed at infinity in a concave lens. So, already I explained you keep that points well in your mind, what is f, what is 2f. When an object is placed at infinity means we can't measure the distance. A virtual image is formed at the focus. You see the diagram, the rays parallel to the principal axis. After refraction, the rays are diverted, we are extending the lines in the same side of the object, it falls at the principal focus F. So, we are marking the principal focus in that point, okay, that is called principal focus. So, if the object is placed at infinity, the size of the object is very, very small, we are getting the image at the same side of the object. Object anywhere on the principal axis at a finite distance. Finite distance means we can measure the distance. So, if we place the object at a finite distance from the lens, from the concave lens, a virtual image is formed between optic center and focus of the concave lens. The size of the image is smaller than that of the object. Object விட ரொம்ப ரொம்ப சின்னதா தான் இருக்கும். So, we are getting virtual images in the case of concave lens. But in convex lens, we get a virtual image in one position of the object. You know very well where we are getting that image, already we have seen. You please go through the ray diagram. If you go through the ray diagram today itself, you will understand very well. Okay. So, these are the images formed in a concave lens through a refraction. The difference between a convex lens and a concave lens, already I explained you, a convex lens is thick in the middle, thicker in the middle than at the edges. Concave lens is thinner in the middle than the edges, that is the edges will be very thick. Okay. And at the same point, it is a converging lens, it is a diverging lens, and then it mostly produces real image. Convex lens mostly produces real image, but a concave lens produces virtual image. It is used to treat hypermetropia. Which lens? Convex lens is. We are going to see the structure of the human eye. In the next session, we are going to see, and the defects of the human eye. Hypermetropia is a defect of the human eye. To correct it, we are using the convex lens. Then concave lens, it is used to treat myopia or myopia. It is also a defect of eye, that is short sightedness. To correct that short sightedness, we are using concave lens. So, these are the difference between the convex lens and the concave lens. This will be asked in 4-mark question. Differentiate convex lens and concave lens. We will see the application of convex lens and concave lens. So, you know very well about what are the uses of convex lens and what are the uses of concave lens. If I ask you, you will answer, you all will answer, Miss, we are using convex lens in cameras. Without the convex lens, we cannot see, you cannot see me in the class. Okay. So, convex lenses are used as camera lenses. Camera lens உடனே உங்களுக்கு எல்லா ஞாபகத்தில் ஒரு கேமரா எங்கெல்லாம் இருக்குது, எதுலலாம் இருக்கும். ஈவன் நம்ம we are having a camera in our mobile phone. So, the convex lenses are used as camera lenses. They are used as magnifying glasses. What is called the magnifying glasses? Magnifying means உருப்பெருக்கம். Next class we will see what is meant by magnifying. Okay. So, magnifying glasses is nothing but to see the tiny objects into a bigger one. So, கைரேகை பார்க்குறவங்களாம் அந்த மேக்னிஃபையிங் கிளாஸஸ், வாட்ச் ரிப்பேர் பண்ணுறவங்க அவங்கெல்லாம் அந்த மேக்னிஃபையிங் கிளாஸஸ் வச்சுருப்பாங்க. They are used in making microscope, telescope, slide projector. Microscope you know very well, telescope it is these are all optical instruments. Microscope to see the tiny objects, to observe the tiny objects like bacteria, virus and other things. Telescope, you know very well about a telescope, already you have learnt. நம்ம ஸ்கையில் இருக்கக்கூடிய galaxies, stars, etc. we can see using the telescope, we can see the objects, observe the objects. And slide projector, you know very well. They are used to correct the defect of the vision called, already we have seen in the differences நம்ம பார்த்துருக்கோம். Hypermetropia, it is the defect of the human eye. Then applications of concave lenses. Concave lenses are used as eye lenses of Galilean telescope. So, we are going to see in telescope part what Galilean telescope, about the Galilean telescope. They are used in wide angle spy hole in doors. So, நம்ம வீடுகளில் சில வீடுகளெல்லாம் ஸ்பை ஹோல்ஸ், வைட் ஆங்கிள் ஸ்பை ஹோல் வச்சுருப்பாங்க. அதில் எல்லாமே ஒரு லென்ஸ் ஃபிக்ஸ் பண்ணியிருப்பாங்க. தட் லென்ஸ் இஸ் நத்திங் பட் த கான்கேவ் லென்ஸ். They are used to correct the defect of the vision called myopia. Already we have seen what is myopia. So, these are the applications of the lenses. So far we have seen the two kinds of lenses, concave and convex lens. Suppose if you are given a lens and find the f, small f, that is focal length of the given convex, for example convex lens. So, we need a formula, no? So, what formula we are going to use? The lens formula, we are going to use the formula, it is called lens formula. The lens formula gives the relationship among the distance of the object u, the distance of the object v and the focal length of the lens. The lens formula is given as 1 by f is equal to 1 by v minus 1 by u. This is the formula. We are going to use this formula to determine the focal length of the both concave and convex lens. The formula is used to solve numerical problem. In the book back la vandu ungalku irukku find out the focal length of the given convex lens or concave lens. So, there are few examples, some given in the book back. So far we have seen the images formed in a convex lens and a concave lens. Suppose if you are asked to determine the focal length of the given lens, that may be a convex or a concave, there is a formula required to determine the focal length. We are using one formula here, lens formula, it is called lens formula. The lens formula gives the relationship between the distance of the object, that is object distance u, the distance of the image distance v and the focal length f of the lens given length, that is small f. The formula is 1 by f is equal to 1 by v minus 1 by u. So, this formula gives the relationship between the focal length, the object distance and the image distance. It is applicable for both convex lens and concave lens. Convex lens ku concave lens ku same இதே formula தான் நம்ம யூஸ் பண்ண போகிறோம். The formula is used to solve the numerical problems that is given in the book back. Okay children, let us see the evaluation part. First one, draw a ray diagram to show the image formed by a convex lens when the object is placed between f and 2f. Differentiate convex lens and concave lens. Okay, let us recall what we have learned in this session. First thing, we have seen what is the lens, then what are the types of lens, that is concave and convex. And the key things we are following to draw the ray diagram that we have seen, that is capital P principal focus, principal axis, capital F principal axis, then optic center, U the object distance, V the image distance and F small f the focal length. Then the ray diagram for different position of the object we have seen, then the images produced in a concave lens we have seen. Children, don't forget to draw the ray diagram, don't waste your time, you go through the lesson. Today itself you draw all the ray diagrams given in the book, then you will be very easy to draw. Okay, thank you.